describing the shape of quantitative graphs. Last time we did categorical with the bar charts and the pie graphs. Those were about categories, you know, like Facebook, Instagram. Today is quantitative data with numbers. So here's how you can describe the shape. It's going to be kind of a lot of vocabulary stuff at first, then we'll dive into it. But like, it's a bunch of different dot plots, like you saw on our activity graphs. I think dot plot showed up. So the first of it is to look for like major peaks. You know, look for some major peaks, not some minor ups and downs, but like major. Do is to look for clusters of values or obvious gaps. If there is any gaps in the graph or just a bunch of dots put together. So we're looking for clusters or gaps. Look for cluster gaps. This is our data. There's some major gaps between 0 and 5, between like 5 and 13 or 14 or 15. Major gaps there. And we have kind of like a peak here-ish and a peak there. So we're kind of looking, is there any gaps in the graph? Is there a peak somewhere? Then the third thing we look for is to decide if the distribution is what we call roughly symmetric or if it's skewed. And that's the big thing. Make sure it's skewed, right? That's a weird word, but if it's roughly symmetric or skewed. And again, this is going to be kind of weird at first. The more we do it, the easier it will become. And these little things that I'm about to draw, I think that you should draw them also on your paper. So the first thing right here is, how do you feel about these dots right here? Draw this little guy right here. And let's go with what they titled it. It is roughly symmetric. Roughly is an important word because it doesn't have to be perfect. Are you guys cool with like symmetry? Like if I drew down the middle of this, is the left side of those dots look pretty much like the right side if I was to like make it fold them over? Like it's symmetric in that case? There's definitely like one peak on this guy. That's like the highest point in that scenario. And there's no real gaps in the graph, you know. The only reason why there would be gaps there is because 1 and 2, then 3. So it's just kind of like the scale on that x-axis. So that is roughly symmetric, right? Then the second one, bimodal. If you kind of make this weird little hump, I just kind of trace the top of the dots and make a curve thing. Bimodal means this. Bi means 2. Like if you have driving a bicycle, it's got 2 wheels, you know. So bi means 2, and modal means mode. From way back in your Algebra 1 days, mode meant what occurred the most. Like you had mean, median, and mode. Mode occurs the most. So how do you feel about those two dudes right there? It's like, so there's 2 modes in that. We don't see very much data that looks like this that often. Then another one is like rough uniform, to where like, it's basically pretty flat. There was not a big fat peak anywhere or anything like that. It shows up in the columns like a bunch, you know. It's like, it's not perfectly uniform to where every single one of them is the same height. It's roughly uniform, right? So these two, the symmetric and skewed ones do. So what's about the skewed is it kind of tells you what kind of brain is some perfectly the way it's supposed to be, and some people see it completely backwards. That is normal in both cases, but check this out. Do you see that this data right here is to the left? But that is weird for a lot of people because they're like, why is it skewed left? All the dots are on the right side, right? And here's how I try to explain that to you also. If I had us like put all of our ages into that applet and made a dot, like go 17, 17, 17, 17, 18, 18, 18, 17, 18, 17, 18, maybe a 16. And then if I put mine in there, 45, would that mess up the class average? What do you think of my age? And it would make it way too big. Are you with me? Because on the graph, like all y'all are the hell over here, all of that data to the right, because that's where the weirdo was, right? The weirdo on the right. You see there's only one dot, like right here, making the class average go lower than it's supposed to be. It's skewing it to the left. the way I usually talk about it is, if I start over here, if I this guy, are you cool that this part I kind of call like a tail? It's like, which side is the tail on the right side or on the left side? Tail's on the left. So how do you see about this guy right here? You see like the tail where it starts to tail off and more weird small amounts of data is on the right side. So that's skewed to the right. So if we would, how do you feel this, if I snip him out and draw, is skewed to the right? Because if I was to make this thing like that, doesn't have those two 40s way over there on the right side totally mess up the average, you know, of like the hours worked with it. Skewed the data to the right in that situation. Most, you know what I mean? Most of the data is all crazy like that. So let's do problems. First, let's learn what SOCV is. SOCV is how we describe the distribution, just like an acronym. S stands for the shape. So that's what we were just doing, like fairly symmetric, skewed right, skewed left. So S is the shape. O stands for outliers. If we did all of our class data about like our ages, I'd be a major outlier in that. 45 doesn't fit the data. C for center. We'll talk more about him in a little bit. And V stands for the variability. Some people call it the spread, like how much things vary. And then we're almost down a couple more chapters, then we just get to dive in. So shape, outlier, center, and variability. The median is the middle. The way I always like to help kids remember that, because we're probably pretty familiar with the interstate, like I-70, you got two highways. The median is that ditch in the middle between those, right? So median means middle. And an outlier, I think you pretty much know what an outlier is. An outlier value that falls outside of some sort of pattern. A value that falls outside the pattern. Like ages of y'all, 17, 17, 17, 18, 18, 17, 17, 18. It's like, it's like, no way does that fit the data. Be cool with all those vocab words. So, man, here is a, anytime it's on paper, I highly suggest that we do one of these guys and talk with your table group. How would you describe that shape? Let's go through these options first. Fairly symmetric, skewed right, or skewed left. Pick from those three. If none of those three might be uniform, what do you think? I like it. Skewed right. Skewed right. This tail is going off to the right side. Again, there are some people who just think that is completely backwards from what it's supposed to be, because all the dots are left, right? But it's where did the weirdos go? They went to the right. And then, until we can do the math on this, which is coming another day, we just have to guess. Do you feel there are any outliers in this data? Yeah. So we'll call him a possible outlier. You can't even really tell where he is because it's not even falling on the scale very nice. So I just guessed where it was, but I don't know for sure if he's an outlier. One of these days we'll do the math behind it to prove. And I called him a high outlier. The reason why is because this data was bigger than all the rest of them. I could do the same thing with ages of people. If all y'all were 17, 17, 17, 18, and I brought an infant in here of 2, you know, it's like that's a low outlier. You know what I mean? So it's like you can have a high outlier. Those are pretty basic once we get used to the shape thing. Then the center and the variability, we should not be missing those when they give us statistics. The center is the median. Can you MED? So our median. Okay with that? And then our variability, I've made that so much easier than it used to be. You just need to know the low value is right here. Isn't that the minimum data in there, right? And you need to know the high value. Isn't that the maximum value? And you just list it like this. It goes from 2 to 49. From 2 to 49. It just varies from 2 to 49. It's always low to high. If we did our ages in here, it goes from 17 to right? That's varies in the situation. Right? Use the summary statistics. Cool. Let's try again. The only thing that made this complicated is they doubled them up on us. They did what's called stacked dot plots. What is important is you try to read stories on homework. You know, a lot of times people start asking me for help, and I'm like, well, do you know what this is even about? They're like, no, I didn't read the story. So here's what it is. They got basically some creeks. They're called brooks, right? But you guys know what a creek is, right? And what they did was they like studied some chemicals in these creeks for pollution, you know, so measuring the nitrogen, some organic that are a main ingredient in the fertilizers. So you know how people like fertilize their grass and fertilize their crops. When it rains, all that stuff. How much of that is running off into the streams? Because that might be affecting our fish. You know, there's some fish in the streams. Is this good for them or bad for them? They just went and measured like how much nitrate pollution was in 2 different streams. One of them's called Stony Brook. The other one's called Millbrook. And it went to 40 different places in the streams, right? 42 different places in Stony Brook. I went like here, then walked down a little bit, and went to another place, and walked down a little bit. They just went to 42 different spots in the stream in Stony Brook, 42 different places in Millbrook. Can you see that here of how many times they took some surveys? Like they did 42 different times each. They say Brook right there. That dot. What does that dot mean? It means when they went to this spot in Stony Brook, there was 12 milligrams of nitrates. Right? Here's how I worded that. Places sampled at Stony Brook had a nitrate concentration of 12 milligrams per liter. One of the places sampled at Stony Brook had a nitrate concentration of 12 milligrams per liter. That's what that dot right there meant. How did I know the label? I looked at the access label on there. One of the places sampled at Stony Brook had a nitrate concentration of 12 milligrams per liter. They ask you to describe them. That's the SOCV. Most of the time I type out what the SOCV stands for, but sometimes they don't. So you got to do the shape, their center, and the variability. Let's go up kind of high. Notice I never really put like, even though it does dip down. And here's where we have freedom, because sometimes more than one way makes sense. I will talk first. What do you think? Fairly symmetric. Your thoughts? Yes or no? Some of you shook your head no. Why did you say no? Cool. He said bimodal, right? You know, I would agree with that if this dude and this dude were the same height, right? You know, like very good. We're learning, right? You know, if they were the same height, I would call that bimodal, but that one is the very, very top. So a lot of times they'll ask that first. How many peaks? There's just one true peak, right? The highest of the high only goes to once. Some other people shook their head no for fairly symmetric. What's your thoughts on that? Why not? What would you feel instead of fairly symmetric? Anybody? Skewed to the right, you know? What do you think about that? Skewed right? Drastically or slightly? Slightly? I'm cool with that. That's what I chose also. But you know what? I would not have been mad if you would have said that's fairly symmetric. That's pretty stinking close to fairly symmetric. But I do like skewed right, and sometimes the homework will say like, right. Way to figure that out. The lesson, right? We just have to guess right now. Do you feel there are any outliers? Discuss with people around you first. Yeah. Just in Stony Brook. That's all we're doing. Just in Stony Brook. Any outliers? So either these would probably be the ones, you know, the right for that to make that big of a deal. So I personally said there are outliers. I can't with you if you did think those were outliers until we do the math behind it. You know, then for right now we're discussing. Now center and variability, not get wrong because it's in what's called summary. Where did I? Right. So summary statistics. The center is the mean. Variability. It just goes low to high. So low to high, what would that be? Or what is high? Yeah. 0 to 12. Like the nitrates that they measured in Stony Brook varied from 0 to 12. Spots they found 0, some spots 12. Why don't you try table group? See if you can describe it with SOCV. If you mess up, deal. We will fix it, right? But see if you can describe that. Shape. What do you think about shape? Skewed to the right is a possibility. Any other thoughts? Trick. And we're still learning. But here, I do see why you say skewed to the right. Is that because you saw like a gap right? I put this curve on the top of it. If you only paid attention to the curve, does it look like that curve has like the same amount on the left side as it is on the right side? So the gaps maybe cause outliers, right, but the data itself, in my opinion, is fairly symmetric. But I like skewed to the right as well. If you put that, I wouldn't count it wrong on a new person who's just learning all this. But as we get better at this, will be probably fairly symmetric. Not perfect, that's why the word fairly is in there. But how do you feel about outliers? Do you think there's any outliers? Where would you think? For some reason, you cool with those two? Why would they be outliers in my eyes? Right there in that. So are they high? The 18 and the 20. High? Bigger than the other? Possible high outliers. And then I actually listed them of 18 and 20. Homework might have you list them. They'll be in the drop-down. But the center and the variability should not be missed due to the fact they tell it to us. The center is at 8.25. Before, I got an extra question before we start homework. And variability went from 0 to 20. Which one varied more, Stonebrook or Millbrook? Which one had greater variation? Millbrook, right? Because the spread is bigger. But I do have an extra question that's on homework. I should have typed it here, but this answer is Millbrook. They're going to ask you to find a percent a couple of times. That's why I have to get a calculator. So I don't go too fast. Make sure all good. I can come back to this slide. But you don't have to write this question down, but let's just do it. What percent of the data are higher than 14? I need to only look at the graph. Say higher than 14. Is this pink higher than 14? Yep. Is this one? This one? But how about this one? That is the question. Is he higher than 14? He actually is 14. Are you with me on that? So we can't do it. But up on these, there were 3 of them, right? Out of, since they asked for a percent, I need to know how many total there were. Thank you, summary statistics, for always telling me the total. How do you feel if there were 42 dots in there, right? So 3 divided by 2, and they want a percent. So I divide that, divided by 42, and they will make us probably go to the nearest 1/10 of a percent. So I'm going to move it 2 places to the right to get 7 point, and then I have to see if I keep this a 1 or round it up. Since this 4 right here is not bigger than 5, it's going to be about 7.1%. About 7.1% is what I think. Cool. I'll let you guys work on homework. It's due at the end of the hour, so let's get that bad boy done. There's definitely some weirder graphs that if you're not sure, I'll help you with. But let's rock it, man. We got about 45 minutes. We should all get it done by the end of the period.